Hello, welcome back to BlenderSushi Live Noding. Today in this video I will try to explore LSystem, which stands for Lindenmayer system. I couldn't give you all the theory about it, but if you maybe use Wikipedia and search for LSystem, you can get like a proper description of it, like the whole theory behind LSystem. Basically, what I get from this, if I describe it using my own word, LSystem is kind of like a way we can use grammar or text to describe kind of a structure or algorithm. I recommend you to look at this LSystem video tutorial by Daniel Schiffman, and then take a look at some videos that talk about LSystem. I actually have a look at this Houdini LSystems implementations. Houdini has its own node that does this LSystem. The one I will be using for to play around with LSystem in Blender is the one for Sverchok. It was developed by Zeffii. He implements this as a script for script node in Sverchok. And this is his Zeffii's blog, blenderscripting.blogspot.com.au. And this is quite recent, in April. Perhaps this is also something that's kind of a work in progress. Not sure if this is like a complete rules, but it's a good starting point if you want to play with LSystem. So I will try to use this Zeffie's LSystem for to explore inside Sverchok. Okay, so we just need to go to his GitHub and then get this Blender LSystem 3D. There is also the 2D versions in Sverchok, but we're gonna use the 3D one. Just grab these 3 files. There's an example rules that we can use for the LSystem. There is this script that's used can output the radius. We're gonna have a look at this one first, 3dlsystem.py. That's a Python script for Sverchok. Okay, let's delete this cube, hide this guy. Let's just jump into compositing, turn on Sverchok, new. Let's file save this as Zeffii LSystem. Explore 31. So how do we start with it? We need to load the Python. So I'm gonna switch to text editor and open, and then I got it here, Blender LSystem 3D. Just grab this is not an add-on, okay, this is like a Python script, so I'll get this 3dlsystem.py, and this script is for Sverchok. So I have Sverchok node 3, and then I will just load the script. We have 3 different script nodes, but I think this will work with the first one. Scripted node, get 3dlsystem, and then before I hit that, if I try to hit that, it will complain, okay, blah blah blah, rules not found, rules. So this LSystem will need a text file named rules. So I'm gonna create another text editor and create a new one and name it rules. So this guy, we're gonna put our rules that we're gonna create to generate LSystem. So there is an example provided by Zeffii. So this is like 5 lines of LSystem rules. It looks like a jumbled up letter, but each one actually has a kind of a function or directions in order for the LSystem to generate our mesh or structure. If I haven't mentioned already, the LSystem is usually used in to describe the algorithm behind things like plants and trees. I also recommend this book, this algorithmicbotany.org. You can download the PDF version. I think this is not the whole book, but it's good enough. Yeah, let's just jump back to Blender. So now we have our rules right here, and we have the script. Let's reload. Okay, it seems to be working. File save as new version. We cannot see anything yet because this is Sverchok, and we need to output using viewer draw. We have the vertex and edges got created. Vertex and edges. It looks like a plant. And we have one properties we can play around. It's the angle here. If it's 0, the trees will just kind of growing up. No, not really. Interesting. That's maybe like this different kind of result, but this is kind of a result that I was expecting. It's kind of like drawing trees like that. And this is really complex if you're not using LSystem. It's not easy to create this, but the LSystem and then this kind of rules will generate this kind of tree structure, which is really cool. I'm probably not gonna explore the whole thing, but I'm gonna kind of break this thing down, or in fact I will copy paste and maybe use this as a guide. So this I'm gonna create a new text file, and this is a Zeffii example. I'm gonna paste it there. The rules that the LSystem gonna use is this one. I'm gonna start from scratch. Just gonna type F over there. So we start with something like this, just a simple line. Okay. If you look at a few articles that talks about LSystem, you will find out that they will use example called turtle. Imagine if you're the turtle and then you're drawing lines. Imagine you're a turtle and you start from a point, and then you ask turtle to go up, and then you ask turtle to turn left, and ask turtle to turn right and turn left. Maybe keep going straight again and turn right and turn right and stop. You kind of create that, and then you ask turtles to go back to this, remember this position, and then you draw another like branch. I don't know, that's kind of what we are doing with LSystem. We are creating rules, and the rules start with the position, the default what do they call it? They call it axiom like that. That's kind of like the starting point. In this case, our starting point is called I. The rules is I, and from that I we can start putting rules. And this is like a bunch of kind of grammar, like a symbol you can use to tell the turtle to draw tree, for example. I haven't explored everything, and I'm not sure if all of this is actually working yet. Maybe some of them still not implemented, but you can give it a try. Let's just explore this. I haven't actually read all this, but let's just give it a go. So from my understanding, F means go straight up. The way I like this to work in Sverchok is to keep the playback running. I keep the playback running, so Sverchok will recalculate the result of L3 each time. This is real time, like it will update right away. So I like this a lot. So if we, with the axiom, if we type in like FFF, we're gonna draw 3 lines because it's we are asking the imaginary turtle to draw 3 straight lines. It goes up by default. We can type FFFF, and doesn't matter how many times, and that's gonna keep drawing keep drawing straight lines up. You can also type in lowercase f, and that's gonna draw like a gap like that. Let me turn off Safari, maybe. Oh, Firefox, slowing down my computer. So we have, other than F, we also have we actually have Z. This is a special. It's gonna draw half of the line, so I can type Z F Z F Z, and it's gonna draw 1 unit, half unit, 1 unit, half unit, and 1 unit. So that's simple enough. We also have lowercase z that's gonna draw half gap, so no draw, half no draw. So we understand 4 different kind of way to draw this. Then we have something called turn left and turn right. Turn left and turn right is a way we are telling the turtle to draw, instead of keep going straight, tell the turtle to turn left. So I'm gonna just give it a try. So let's say if I just type plus, it's a plus or minus. Plus mean turn left, so plus, and I type another F. Seems like it's keep going up. That's because of this angle. The angle needs to have a number. So if I just maybe give it angle of 270, it's gonna be doing that. 180, and 0 is actually straight up. Here I found this to be a little bit confusing. Maybe it's in a radian, or I don't know what angle. But if I type in 90 here, 90 like that, and here I use this bracket and type in 0.5, I gonna get this more proper angle. It looks like 90 degree to the left. Let me stop the playback and then make this like 10,000, and now play back. So yeah, this angle thing will be will influence the number you put here. So I don't know if I think if I put 1.0, that means it's gonna turn. Let's say I put in 30 degree, so it's actually the turtle is turning 30 degree probably from the center line like that. But yeah, there's kind of math behind this. But anyhow, I like it to just visualize the result. Don't care so much about the math. But if you have the angle that's positive, it's gonna turn left. If it's negative, it's gonna turn right. For now, keep the angle positive, and knowing that if we use plus, symbol plus, that means it's gonna turn to the left if we are looking at from this angle. It's gonna turn left, and then if we use minus, gonna type in minus 1.0 and type F, it's gonna turn right. And you can continue doing that. Keep if you type in like F, it's gonna keep going straight. But if you are typing like plus F, plus F, plus F, plus F, it's gonna make a round. It's kind of doing like a spiral now, which is interesting. Plus F. You can also do like a plus 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 and then minus minus minus, and that will affect the where the branch gonna grow. So that's the first thing to understand. The next thing that's interesting is actually the bracket. This bracket, store location rotation and restore location rotation, is kind of in programming terminology. You have like a push and pop, kind of a way to kind of reset the position. Kind of like, let's say we're drawing FF, we're drawing two straight lines, and then we want to remember these positions, and then let's say we are turning left, and then we draw another F, or we are turning to the left twice, and then draw F, F. We can go back to that point here, and then draw another line from that point. Maybe I should use minus minus. Like so. Maybe I need to give it a number. Oops. Division by 0, that's bad. Okay, maybe I don't need floating number here, just 3. Maybe here just 2, actually 2. So if you are doing it like this, you're kind of creating branching. So to make it really clear, I will do F F F F like 4 times. So that's 4 times straight lines, and then plus 2 is like a turn left and draw 2 straight lines, and then turn right and draw another 2 straight lines. So, and I'm gonna save here just in case it crashes. What happens if I draw another 2 line? Okay, I can't see anything. Maybe I'll use like -2. What happens if I put a minus there? Nothing. Yeah, so we have like 3 branches just by typing this weird sentences. The angle will still affect the result, like that. So at this stage, I really still kind of doing it like a trial and error. It's hard to see the direction actually. There is a roll and roll horizontal. Not sure if they are working. There's a left roll and right roll. This is probably, I know that these two gonna work. But for now we don't. Let's try. We won't do the left roll and right roll yet. Instead, we're gonna create more rules. So this is the first rule. Let me stop the playback. Okay, this is our current result. If you see the example from Zeffii here, you can see that the first one, the axiom is I. It needs to be I, but the rest of them you can make up your own rules. With the I, you can have it. You can tell it to generate itself I, and do like iterations or recursive iterations. I don't know. And then you can also use other rules like F, G, E, H, and these rules can also take create its own rules or following the next rules. So you can kind of mix and match the rules, and then LSystem will handle everything and generate something for you. Let's try. Let's give it a try. So here we have three branches. Let's say if we have A and B, and then we make a new rules. A, maybe Z, and another rules B, Z. Remember to put a comma here. This is like almost like kind of like Python dictionary. You need to have like one rules and then comma and then another rules, comma, another rules. The last one doesn't have comma. So AA, ZZ, B, ZZ as well. Maybe B can be a ZZ and Z. And let's update it. So now we can see. It's actually drawing on the third branch. It's drawing the AA and BB. Let's say if you're drawing A over there and drawing B over there. and A there. Now we can see it. It's kind of drawing the first. This is the first one going like that, and then the second one inside bracket. Maybe one of these, and then that and that. It's drawing A, B, and this one can be A, B. Like that. So yeah, that's it's pretty interesting as you continue adding rules. There is one special symbols that you might want to use is this X random turn. I'm gonna turn randomly. Let me try put the random turn on A and then update. See now every branch with A is turning. No, in fact it's actually turning, it's affecting almost the whole thing with A. A XZ, so it's replacing, because we have A right there, it's replacing it with this XZZ, and then it's also affecting this guy. Maybe I'll put this inside bracket. Update. Oh, it's because this guy have A. Don't want it. Yeah. Maybe turn off random for now. It's a bit confusing already here. FA, maybe I get rid of one F. This can be -2 or 1.5. Update it. Set. What's interesting though is we can actually mix A and B and mix it with I as well. So I can actually put I right here and updating it, and suddenly we have like 5 times iterations. I think I can actually put the I inside the rules A. It's gonna update and it's gonna generate that. Put the I here. Soon you have like quite a complex structure. Maybe here you can just randomize the whole thing. And if you want, you can bake it out and render it out as curve, or using skin modifier. It's gonna work with this mesh result. Let's turn off the X once again. So yeah, let's try some of these rules that Zeffii give as example. This one is particularly, let's say we are just grabbing this guy and copy and then paste it here. Some of them might not work, but we can kind of have a look real quick. Okay, F, Z, FF, F, small f. We can actually probably just use this. Yep, it's actually working for us. We can also put the B right here, and then look. And let's adjust the angle 10. Again, we get another kind of random structure. I believe we can push the iterations. You can push the recursive a little bit higher. By default, it's like 5 iterations. Maybe increase this to 10. I don't know, it might crash. Didn't update. Maybe I need to reload. Nothing. Okay. There you go. It's 10 times 10 iterations, and we get this kind of structure. And at this stage, you can probably use something like pipe. There's also a skin modifier inside Sverchok, if you don't know it yet. Skin measure. This will generate skin modifier, kind of quite smart. We're not gonna use that for now. Let's try this tube first. It might be a little bit heavy. Hopefully it doesn't crash. Plug in the edge. Size. Calculating. Yeah, the L system can be pretty heavy very quickly. But if you have if you kind of create a certain rules that create like generating 3, you can reuse that rules with slight variations, and then you get another different tree. I don't know yet how complete this code at the moment. Have to ask Zeffii, but give it a try anyway, because you might create a rules that's actually working really well. And ideally, I think ideally the L system could help you to generate like a tree with branches and leaves and flower. I think some people actually use L system to generate a like a lightning kind of effect as well. So that, yeah, this is quite nice. We can randomize the rules or add more rules or reduce it. See, anything you change here will affect the result right away. And that, maybe I just maybe I copy a little bit of this and just paste it here and put the eye there, put the eye there, and then so it might crash actually. So it doesn't generate anything. I think I made a mistake somewhere. Here. Try grabbing this, paste it there, paste it there, and then maybe this plus. Just randomize this slightly. Save it and update. I think with L system you need a little bit it's not so much about the math, but it's more about kind of generating like this grammar. Probably it's a good idea to go back to like a simple structure and try to understand where the angle is going. Yeah, let's just wait a few seconds. I might be generating too many iterations here because I put the I rules for I put it A, and then I have also B that's have I inside it, so it's like it's multiple iterations. Probably it can be quite heavy. Let's wait a few more seconds. It's probably I think it's a good idea if I just try some rules and then take a snapshot of the result and put it on my blog. It's gonna help, I guess, because the LSystem thing is it's kind of huge. It's kind of really simple. It's simple rules, and you can try it, but yeah, you never know what's the outcome's gonna be. That's why it's like the algorithm of nature. You can never really tell where the tree branch is gonna go. Okay, I guess I can end this live noding right here. Blender might crash, or it's gonna come up with something in the end, but yeah, I guess this is just like an introduction for LSystem. Hopefully you find this useful to create your own work. You can leave the comments and give like if you make your own like a result. Please let me know. Show it to me as a video or email me. Yeah, so I'll see you on the next video. Thanks a lot for tuning in. I'll see you next time. Bye.